Hello and welcome to another math video. This video is for the Chapter 1 and 2.1 FST test. We'll get started here with number 1. We just need to list the elements for the set. Let's see, so we write that with our set bracket, or brace. And x is a natural number less than 8. So natural numbers do not include 0, so I'm just going to go 1, 2, 3, ... less than 8, so that would go up to 7, but not include the 8. You could write them all out if you wanted to, but again, we can shorten that up a little bit. Number 2, same thing. A is an integer greater than -2. So greater than -2. So we would be looking at -1, 0, 1, and then would continue on like that. Starting with number 3, we're actually using Setbuilder Notation. So the numbers 14, 15, 16, 17. So simplest way to do that is say x such that x is an integer between, and since we're saying between, we have to say 13 and 18. And that's probably the simplest format to use for writing that in Setbuilder Notation. Number 4, similar idea, Setbuilder Notation, but notice this one is unbound, starting with -2. So that'll be a little bit different. We'll say x such that x is an integer and I'm just going to say greater than -3. Again, you could say greater than or equal to -2 if you wanted to. So there are a few variations you could use there, but this one works out pretty well. 5 and 6, we're listing the elements of the set that are of the indicated type. So we're looking at whole numbers for number 5. So 12 would work. Whole numbers do not include negatives. So -23 is out, and the square root of 7 is not a whole number. That would be irrational. 0 and 0 over 6 would both be whole numbers because they're both 0, and the square root of 16 is a whole number. Number 6, we're looking at irrational numbers. So negative square root of 16 is rational because that's -4. So is 9. Square root of 8 is irrational. Those are all rational. Pi is irrational. -3 over 0 is not a number. You cannot divide by 0. And 0.49 is rational. And so that's what we're looking at for number 6, just the square root of 8 and pi. For 7 and 8, we're looking at some absolute value expressions. So the absolute value of -18 would be 18. And then minus the absolute value of -22, which would be 22. So 18 minus 22, and that's going to turn out to be -4. Same kind of thing with number 8. Absolute value of -6 would be 6, minus the absolute value of 13, which is just 13. So 6 minus 13, and that would end up being -7. For 9, 10, and 11, we're using interval notation. Again, it looks kind of like an ordered pair, but it's not. So number 9, the values of x that are greater than 4, so we would have a parenthesis and then a 4, go up forever, so an infinity, and then another parenthesis. Number 10, the values of x that are less than or equal to -5. It can be helpful if you want to graph it, then you can see what you're dealing with. In this case, -5 there. We're looking at the values of x that are less than that, so it would go this way. That can help you see that the interval would really be -infinity to -5, Now the -5 also gets the bracket there because the inequality has the equal to. And then we get to number 11, which is compound inequality, or three-part inequality. Again, if you wanted to graph it, that might help you see what's going on. But really we just have a bracket, and then -2, and then 3 with a parenthesis showing that it's that interval from -2 just to less than 3. And then number 12, graphing this on a number line. Again, remember we are using parentheses and brackets rather than open and closed circles. So looking at that, all we really need to do is put a parenthesis at 4 and show that that's going to the left. We're doing the same kind of thing for 13, just graphing that. Let's see, so we have a bracket at 0, and we are going to the right because we're looking at the values that are greater than or equal to 0. And then 14 is that three-part inequality, so we have a parenthesis at -1. See if I can do that a little bit better. And a bracket at +2, and then it's the stuff in between there, so from -1 to +2. 15, there's just 5 x's there, so we just write that as x to the 5th power. 16, we do need parentheses around the 2/9, and there's 7 of those. For 17 and 18, we're just finding the square root. 576, probably one you don't know off the top of your head, but you can use a calculator there. It does turn out to just be -24. 18, what I would look at doing, just square root the 36, square root the 49, we get 6/7. Please use the fraction there. Number 19, we have to simplify that. Let's see, in the numerator we would add the 4 and the 4 together first. So we'd have 3 times 8, plus I can go ahead and multiply the 3 and 7 together, get 21. And then in the denominator I get 3 times 6 because I do the 7 minus 1. In the numerator, I would multiply the 3 and the 8 together and get 24, plus 21. And then in the denominator, 3 times 6 gives us 18. Add the 24 and 21 together in the numerator for a total of 45/18. And that does reduce to 5/2. I'm okay with the decimal 2.5 because that is exact. We follow the same kind of process for number 20. Looking at that one, we start with we can do the 5 times -7, get -35, minus the 5. I have to do the 2 cubed before I can do that multiplication, so that's 5 times 8. In the denominator, we do the square root of 121 first, and so it looks like this. Again, in the numerator, that's a 5 times 8, so we can do that first. The minus sign I'm just going to leave out there, so we get -35 minus 40. Now in the denominator, be careful how you handle that. You might want to think of that as adding a -11, but I'm going to go ahead and add the 10 and subtract the 11, or add the -11. I'll get -1 plus 10 there. So I end up with -75/9 as my answer for that one. And that does reduce down to -25/3, reduces by a factor of 3. That looks a little funny, but that is -25/3. And again, I'm not interested in the decimal there, because a repeating decimal. For problems 21 and 22, they give us values to plug in. Let's see, so we start by plugging in the value for C, so we have 8 times 7 minus 3 times B, which is 16. Let's see, we can do the 8 times 7, so we get 56. 3 times 16, we're looking at 48. So we end up with 5 times 8, which would be 40. Same sort of idea for number 22. 4 times c. C was 7 minus a squared. A was negative 5. Now again, be careful when we square that negative. That'll turn out to be positive. Whereas in the denominator, 7 times negative 5 will be negative. And then we're squaring the c as well, so squaring 7. And so doing the 4 times 7 gives me 28 minus a positive 25 over negative 35 plus 49. 28 minus 25, that's not too bad, it's just 3. And then really like a 49 minus a 35 would be 14. So 3 over 14 for that one. And then we're looking at simplifying some expressions. So we need to distribute the negative 12 into those parentheses. So we get negative 132z. I should probably try not to make my 2's and z's look so much alike there. So negative 132z. And then we get minus 96m. So negative 132z minus 96m, again making sure that we distribute that negative all the way through. Number 24, we distribute the negative 5. So we'd be looking at negative 10x. Then it would be plus 40. Again, the negatives cancel out. Minus the 4x plus the 6. We can combine the x's and get negative 14x. And then add the 40 and the 6 together, we get 46. And then we'll take a look at 25. This will be the last one for this video. Starting to get a little bit long, and so the last page will have its own video. So we start by distributing that negative 2, so we have negative 4m plus 4 plus, and then we distribute the 4, we get 12m plus 20. And we can combine m's, so we get a negative 4m plus a 12m for a total of 8m. We can combine the 4 and the 20 for a total of 24. Well, as always, thank you for watching, and hopefully you found this to be helpful. And as I mentioned a minute ago, again, we'll do a separate video for the last page of this test.